Hi guys, in this tutorial I'm going to solve question number 6, paper 42, November 2021. Block of mass 5 kilogram is held in equilibrium. This block will start to show the horizontal and the vertical, so you can resolve all the forces horizontally and vertically at the block. It's clear that it's given its mass, so it's better to show the weight, which is acting vertically down. This is the weight. Mass is 5 kilogram, so the weight will be 50 Newton after using G is equal to 10, 50 Newton. The string, we have a string, and we have force X acting to the right side as shown. The two strings are both inclined at an angle 60 degrees to the vertical. This is not a particle, this is a block. So I will name this tension 1 and this tension 2. Makes an angle 60 degrees by using alternate angles. So this angle will be 60 degrees and this angle same will be 60 degrees. So you can use it to resolve the force T1. T1 cosine 60 and T1 sine 60. And the tension 2, T2 sine 60 and T2 cosine 60. The block in equilibrium, so f of x is equal to 0 and f of y is equal to 0. This means the forces acting to the right is equal forces acting to the left. By looking at part A, it's given x is equal to 100, x is equal to 100. So f of x is equal to 0, form an equation, and f of y also equals 0, form another equation, and solve the equations simultaneously. I write the first equation, T1 sine 60 plus T2 sine 60 is equal to 100. Second equation, all the forces acting up, which is T1 cosine 60 is equal to T2 cosine 60 plus 50. Or if you write f of x 0, f of y 0, then you will get the same equations. You can rearrange. If you move T2 to the other side, will be minus, and it is equal to 50. So now it's easy to solve the equations simultaneously to get T1 and to get T2. You can use elimination, you can use substitution method. I will use the calculator by solving a simultaneous equation. Write the first equation, sine 60 equal, then again sine 60 equal 100 equal cosine 60 equal negative cosine 60 equal 50 equal. So the first one is 107.7 and the second one is 7.735. He asked to find the tension in the lower string. We name lower is T2. So T2 will be 7.735. Three significant figure will be 7.74. Part B, find the least value of x for which the block remains in equilibrium in position shown. The least value for x, this happens when we remove the string down. If you remove the string down, so now we have how many forces? We have 3 forces only. Now we have 3 forces under equilibrium. try now to find the value of t and value of x. So when we remove the string down, we have tension. Repeat again, start to use resolving method, or I will apply Lam's rule method. By using Lam's rule, because we already have now angles between all the forces, the measure of this angle is 150 degrees, and measure of this angle is 120 degrees, and the measure between the weight and x is 90 degrees. By using Lam's rule, force T over sine opposite angle, which included between the other two forces, which is 50 degrees. So T over sine 90 degrees is equal to the force 50 over sine 150. 50 over sine 150. So the value of T is 50 sine 90 all divided by sine 150. So tension is equal to, he asked to get the value of x. So x over sine 120, sine 120. If I ask it to get x, only will be 50 times sine 120, all divided by sine 150. So 50 times sine 120, all divided by sine 150. So the answer exact is 50 root 3, or as decimal, x is equal to 86.6 Newton. And in this case, if I ask to get t, you can find it from the first part. I will explain this part again by using resolving method. If you use resolving and solving equation, this is the block. After resolving the components, this is x, this is 50, and t cosine 60, and t sine 60. X equals t sine 60, t cosine 60 is equal to 50. I will start with t cosine 60 is equal to 50, so you can find the value of t is 50 divided by cosine 60. You can keep it like this, or you can find the exact value, which should be 50 divided by cosine 60. So the answer will be 100. Then x equals t sine 60. So t is 100 sine 60. 100 sine 60 is equal to 50 root 3. This is the exact value. So x is equal to 86.6 Newton. Same answer. That's it. Thank you.